Please welcome the representative of the French National Conservatory of Arts and Crafts.
Hi, my name is Zacharias Amara and I'm an associate professor at Sinet in Paris in organic chemistry. As a chemist, a father, and a citizen, I see every day how much our world and civilization depend on fossil fuels. While chemistry has brought us so much progress, from medicines to materials, this comes with a high environmental price, as nearly all chemicals are derived from fossil fuels. Today, chemistry needs to transition to a circular economy and low-carbon economy. But to succeed, we need to find a fossil-free supply for a whole family of essential chemicals. Linium Biochemicals has unlocked a scalable and robust solution to do so, and that's why we nominated them, and we believe they should win Falling Walls Ventures.
Breaking the wall to circular and low-carbon chemistry. Ludovic, Sinet. Linium Biochemicals.
So, good afternoon, everyone. So let's start with a little bit of chemistry. So this is a molecule called benzene, and this also called an aromatic ring. This is actually the basic structural unit of a whole family of essential chemicals called the aromatics. And so I will use benzene as a symbol to represent aromatics. So aromatics, they are critical. They are 40% of all chemicals in volume. Just in the EU, 120 million tons per year. They are everywhere, from jet fuel to insulation foams, to adhesives, to cosmetic ingredients, to pharmaceuticals. So around us, on us, and inside us, we need them every day. But we have a problem. Like most chemicals, they are made out of oil, with coming with quite high carbon emissions, too often toxicity, and a price volatility. So the question is, how could we make greener, better aromatics? Well, actually we can, but there's only one alternative. It's called lignin. Lignin, as you may know, is a biopolymer. It's a major waste from the wood, the paper, and bioethanol industries. And it could serve to make aromatic chemicals. But today, the industry and the technology is unable to do so. So that's exactly where we come, Linium, and we basically replace oil with lignin as a feedstock for aromatic chemicals, slashing down the carbon emissions, reducing the toxicity, and enabling more stable prices. How do we do that? We are developing our lignin biorefinery process that relies on robust and scalable chemistry, no pricey catalyst or reactors. And that enables us to break down lignin in a very selective way, getting only 2 small molecules on one side and polymers on the other side. But we don't stop here. We go even further down the value chain and capturing more value from the market. We, again, have our own process, and we transform our 2 platform molecules into pharmaceutical cosmetic ingredients and antioxidants. So that's something that sets us apart from the competition, because usually they stop here, but the value is quite limited. And we go to a way better and higher value here. In the meantime, we work with co-development partners to upgrade and incorporate our polymers into their materials, being building materials, packaging, and so on. So bigger volume, lower value, but big impact. In terms of product strategy, there's something to realize in chemistry is that each molecule is a different market and requires a different process to get there. So you need to make a really wise and pragmatic choice while keeping the technical simple. That's what we do. And we start with a pharmaceutical intermediate, small but easy market, mainly made in Asia, where we're able to actually offer a lower price in a local supply chain, which is important in pharmaceuticals. And then from that easy market, we go further up towards multi-active cosmetic ingredients and antioxidants. Bigger market because we're here dealing and trying to replace these molecules around here. So what we offer here is a new combination of action, which is always looked for in cosmetics, and while still being actually bio-based and still offering a lower price for these actions. And of course, for the polymers, we can go even further by offering polyols and polyphenols replacement for commodity players. Big market, offering here low carbon replacement and a better toxicity profile for these products and these polymers. In terms of development, where are we? We incorporated early last year, and with the support of investors, governments, and ecosystems, we are now scaling up out of the lab. We will have like basically dozens of kilograms of our products very soon, in a few months. And from that, the goal is to test and validate with industry our products, then getting to the seed round, and you know the startup story. You then scale up to the pilot ton scale, we commercialize it, you raise again, and we reach what we believe we need to reach, which is a demonstrator scale. And we believe that's where we need to go before we're able to either industrialize any further or to license the process. Of course, with a lot of pain and tears to get there. Regarding our team, who are we? So we are two co-founders, myself and Zakaria, just met, who is an associate professor in chemistry and also a pharmacist by training. So we have 3 rock stars in the lab, but also we are well surrounded. On the science side, we actually have 4 people, 3 Germans, country of chemistry, and so like people from the pharmaceutical industry, BASF, and prestigious universities. And on the business side, we are surrounded by people from the distribution of chemicals or scale-up companies producing new chemicals. So myself, I'm Ludovic Sinet, co-founder and CEO of Linium Biochemicals, and we're working to decarbonize and make aromatics circular out of lignin. Thank you.
Bon timing. Okay, let's go with questions. We take the ones in French first. You go, Iris.
Sorry, I can do Dutch if you want. I was wondering if you could talk a little bit more about the process itself. Like, how does it work and how do you manage to achieve high selectivities? Because as you showed, like lignin is a super complicated molecule.
It's basically it's one type of depolymerization process of lignin, where we're playing, it's an approach that is really selective in terms of the bonds you can break down in lignin. And we play on something which right now we are protected so I can't tell much about it, but we are using like only like accessible and easily accessible chemicals to make this thing, to break it down.
Okay. Next question. That was a clear pitch, if you have no question.
No.
Anyone from the audience? Oh, yes, here. Okay. Marie, you go.
Thank you. What type of lignin you use? Where do you get your lignin from which process?
It can work on any lignin. So it can be paper lignin, can be bioethanol lignin, it can be also wood directly.
Okay. Next question. Anyone? Yes, here, please. That's nice that the audience is participating.
What are the type of bioproduct that you get after the purification step?
So we basically get like 2 monomers, and then we do the chemistry out of it towards our product. And the other side, we get like lignin oligomers. So basically a long chains of, smaller than lignin, but chains of lignin, that looks like polyols or polyphenols,
Okay. Next question. Good. Yeah. A shadow, yeah.
Hey, quick question. You mentioned a seed round, 1.2 million. Can you share who those investors were?
So it's business angels from France, like mainly veterans from the chemical industry and BPI friends.
Another question? Anyone? No? 3, 2, 1, 0. Thank you very much.
Thank you. Thank you.